Hello, welcome to the next video for coastal environments, looking specifically at what's going on with coastal landforms. So we have looked at coastal erosional features, and we're going to now move on to what's happening with the depositional side of things, with a little bit of erosion going on as well. I said in the previous video that with rivers you get erosional features, erosional and depositional features, and just depositional features. It's similar in coasts, but you kind of get a little less erosional and depositional features. It's more depositional, as you'll kind of find out in a minute. So the first thing we want to look at is how a beach is formed. So coasts are typified by their beaches. So you go to the coast normally for a beach. And so beaches are created in a very, very simple way. Depending on what type of beach you're looking at, depends on what type of environment it's in. So if you remember back to a few videos ago when we looked at the types of waves and we looked at destructive and constructive, constructive makes really wide, gently sloping beaches, whereas destructive makes really steep beaches and quite narrow beaches. It also, depending on the wave, depends on what type of sediment you're going to get. So if you get constructive waves, you're going to get smaller sediment because it's low energy environment, and so you're going to get the smaller material being deposited. If you've got the destructive waves, you're going to have bigger materials. You're going to have pebble beaches or shingle beaches forming because you've got much higher energy that is then depositing much bigger material. So beaches form basically in a 5-stage process. You can probably whittle this down to 4 stages, but mainly you've got deposition happening, and that is the main process. You get a bit of erosion as well, and that's why I said there's some erosional and depositional features even that we're going to look at in this video. But it's mainly deposition. And so what happens is you get limited energy in an area, low energy conditions, and that leads to deposition of material. As I said, if it's higher energy when stuff's being deposited, it's going to be bigger material, so little pebbles and shingle. If it's really, really low energy conditions when stuff's being deposited, it's going to be sand, and the lower the energy, the finer the sand is going to be. Beaches form specifically where there are sheltered bays. Occasionally you get beaches forming at the end of a headland, but that's in very, very certain circumstances which we won't get into. But the majority of these beaches that you're going to be looking at are going to be forming in the bays where the energy conditions are lower enough for the material to be deposited. Stage 5 on this is very, very important. Beaches are constantly changing, so you can go to a beach tomorrow and it might be a really wide, gentle, sloping beach with loads and loads of sand, but then in 2 weeks' time, after a heavy storm, the beach might be full of shingle and full of bigger material. It might be a lot narrower and a bit steeper. And that's because the waves are constantly changing, their energy changes, their intensity changes, which can lead to the change of a beach. And so beaches are very much depositional features, but also there's a bit of erosion that goes on to change and mould the beach. As I said, it's a very, very changing environment is a beach. You might get a question on how a beach is formed. Normally the question won't be more than a 4-mark question. So remember, just that's kind of 4 stages in what's going on. I've been through this, but just to kind of show you what's going on, you need to understand really that obviously the different energy conditions lead to different material being deposited. So I've just put some pictures on here. This is in Dorset, so you've got quite big angular, well, big rounded and some angular material, which is forming a shingle pebble beach. But then you've got these beautiful white sandy beaches. So the top image is where you're going to have much higher energy conditions depositing material, and then the bottom one, much lower energy conditions. But you can also see, this beach isn't very wide at the top, so it's going to be a destructive environment, whereas these beaches are quite wide and quite gently sloping, so they're going to be more constructive environments. Something else that happens along the coast, specifically linked to deposition, are something called spits and bars. Now, just like with waterfalls and gorges being pretty much the same processes going on, and meanders and oxbow lakes. Well, spits and bars link onto each other. So if you ever asked to explain how a spit forms, you then automatically explain how a bar forms. If you're asked to explain how a bar forms, you explain how a spit forms. So it's linked processes. This is a picture in the Vendée. This is a really, really beautiful part of France. And you can see here, through the clouds, a spit. So this is a spit here. And it's a bit of land that basically juts out into the sea, but it's not hard rock. This is entirely made out of sand and silt and sediment. And they form because of deposition. And they form where a river here is meeting an ocean. So in this case, you've got, for the Vendée, it's the Atlantic here, meeting this river called the River Lelay. And so what happens is as the river comes and meets into the ocean, it creates a low energy environment where material can be deposited. And to show you this in a few series of images, I'm going to show you this animation. Now, the processes going on here are called longshore drift. Longshore drift is a type of deposition that's going on. It's kind of a mixture of transportation and deposition mixed into one. And so what you get is a coastal environment, I should say, that looks like this. So you've got a river coming into the sea. So you can see the river coming in from the top of the image, and here's the sea. And the land here is kind of at a bit of an angle to the sea. And what happens is the waves come in at an angle. As the waves come in at an angle, they push sediment onto the beach. And as it pushes sediment onto the beach, remember that's called swash, it pushes it on at an angle. But then what happens is that when the wave retreats, it pulls back material at a right angle to the beach. And so you get what we call a zigzag longshore drift motion going on. And so material is moved up the beach in a zigzag fashion, like is being shown currently. And so the waves push it on at an angle, and then backwash pulls the material back at a right angle, moving the sediment up the beach. And as it moves up the beach, what happens is it then eventually reaches the river mouth, or an area, it might be a bay, for example, where there's low energy conditions. And as it hits this environment, the material that's being moved by longshore drift can then start to be deposited out into the river mouth or across the bay. And as it's deposited across the bay or across the river mouth, that is what your spit is. Okay, so this is the deposited material formed by longshore drift that's deposited out into a river mouth or across a bay. And as the waves come in, it's going to curve back the end of this spit, and we call this a recurved point on the spit. What will eventually happen as well, a salt marsh can form behind the spit, and that's because the spit basically forms its own kind of enclosed area behind it, and a salt marsh is where material from the river is being deposited behind this spit, but also it mixes with a bit of salt water from the sea, and it forms this salt marsh, which is a very unique ecosystem, which we won't get into here. If this process continues, and this spit forms right the way across to the other side of the river mouth or across the bay, it then forms a bar. So as I said, a spit and a bar are pretty much the same thing. A spit is partially across a river mouth or a bay, whereas a bar is fully across a river mouth or a bay. And what will happen is that process will just continue to happen, but also it's continually eroded as well by the sea coming in and a little bit by the river coming out. But the reason it's forming here in particular is because that's low energy, because as the river meets the ocean, it kind of slows down both waters enough to deposit stuff. So that's how a spit and a bar form by the process of longshore drift. This here is an example of a spit called Spurn Head, which is down in Humberside on the east coast of the UK. And you can see here it's curved right the way around. So this here would have been kind of the end of the headland. This is the sea, this is the North Sea. There's a river, the Humber, is coming in from the left-hand side of the image, and it leads to the deposition of the material. You can see also here is the kind of the salt marsh that's forming. There's like a lagoon as well that's forming behind it. My spurn head is constantly moving, so it's extending down, kind of down towards the bottom left, extending outwards, but also it's being eroded by waves from the north at the top of the picture. Also, the depositional features we get are sand dunes. So sand dunes are found across the UK. You can see that by all the yellow dots, red dots even, that are on the picture here. So all across the UK, and these are different ecosystems that are found. Sand dunes are formed because, again, of deposition of sand, but these are not formed because of any processes in the water. They're formed because of what's happening on the land and with wind blowing sand onto the land. And so what you get with sand dunes is you get a nice flat, wide beach. You need lots of sand to be able to create the sand dunes. That's one of the key conditions. And what happens is obstacles like driftwood, or it might be a dead tree or something, are found along the beach. So that's here, so the obstacles. And these might be deposited by the sea. It might be bits of rock as well. And what happens is wind blows sediment onto those obstacles, and over time it will build up a mound of sand, and we call that an embryo dune. And what happens is this embryo dune will continue to build and grow because it's got different vegetation growing on it. Now the vegetation that grows on it is here, and we call it pioneer vegetation, pioneer being a first of a species or a first of a people that arrives in an area. And so this is called marram grass, this pioneer species. And as it grows, what it can do is, you can see its roots there, trapping more and more sediment that's been blown in from this wide sandy beach. And as it grows, a bit of the marram grass might die off, and that marram grass will then create nutrients that then is added to the sand. Now sand is a soil. You don't think of it as a soil because it's not a very good soil, but it is a soil, and there's more biological material, more nutrients are added from the decomposing plant matter. That creates then better soils, and as it creates better soils, it then means that other plants can move in and actually colonize the area. So leads us nicely onto this diagram here. We've got different kind of stages of the dune. You don't need to know these in depth, you just need to know how dunes form effectively, and then also what it leads on to. But so you get these dunes here forming, the first 4 dunes, which are the baby dunes, which are easily blown away. You get the embryo dunes, which we've talked about, which are stabilised by different types of pioneer species grasses, which then makes the dunes grow bigger and then create big 4 dunes. Sometimes the dunes might blow out or hollow out because of a massive storm or something, which creates a slack, which is a saltwater pond basically in the middle of the dune system. But then further on land, you'll then get what we call scrub and woodland. Now you get the scrub and woodland forming because as you continue to get further on land, you can see the colour of the soil here is changing because you've got more nutrients being added by the different species of plants that have died and then added to the nutrient levels in that soil, which means that different species can then start to form and start to grow as you get further inland from the beach itself. And you can see this if you go on holiday, that right at the beach front you've obviously got the sand and some sand dunes of grass, and then further inland you might get the bushes and trees forming because of this vegetation succession. Marram grass is one of these vegetations that start to form. Marram grass is really interesting because of how it's adapted. So you can see it's really tough marram grass, and it's really well protected against the sand and the wind and the salty conditions. It's got different levels of root as well, which means that it can quickly grow and then quickly recover if there's a massive amount of sand that's added to the top of the sand dune, which means it can continue to grow and also stabilise that dune system. So we've looked at a number of different depositional features. We've looked at beaches, spits and bars, and sand dunes, and you need to be aware of how these different things form, under which conditions and through which depositional processes they form by. Thanks very much. Hope you enjoyed the video, and I'll see you next time.